I will now look into empirical formula. First of all, the definition for the word empirical formula is the simplest atom ratio. So if you did have something, let's just say for example like C5H10, which is pentane, and you want to write it in the simplest possible form, it will be CH2, and the CH2 is the one that is the empirical formula. You should also be able to do a empirical formula calculation. Take a look at this question. Calculate the empirical formula of a compound containing the mass of potassium, mass of iodine, mass of oxygen. It could be either given as a percentage or a mass, but you treat it in the same way. Right, the elements at the top. First of all, I will write the mass, which is given to me. It could either be the percentage or the mass, either one is fine. 1.82, 5.93, as well as the 2.24. I will then write the MR values of them, which are going to be 39, 126.9, 126.9, and your 16. Once I've done that, I do step number 1 divided by step number 2. So I do my mass divided by my MR. Technically, we're actually getting the moles of that. So we do 1.82 divided by 39.1. That's going to be equal to 0.0465. Then we're going to do the 5.93 divided by 126.4.9. Sorry, that's going to give you your 0.04672, and we're going to do your 2.24 divided by 16. That's going to give you your 0.14. Then to get the empirical formula, all I simply do is I divide through by the smallest value in step number 3. So the smallest value in step number 3 is going to be the 0.046. So if I divide that by itself, it's 1 to 1. And if I do the 0.14, divide that by 0.04672, I'm going to get that to be 2.99, so we're going to get that to 3. So the final empirical formula ratio is going to be KiO3.